building bigger seawalls
Yep.
by coastal communities.
Yep.
And mitigating is trying to stop the change from happening.
Exactly. So great segue. So for those of you that are listening, today we're talking about different kinds of carbon policies or modalities. And we're tying it into the last lecture where we talked about adaptation and mitigation. Adaptation, recognizing climate change is here, and we've got to do something to make our cities and our coasts and our watersheds more resilient and our biodiversity more resilient, but also mitigating it, trying to reduce the future impacts by making policies to ratchet in carbon. Okay, so there's two basic market solutions, and of course, like anything that's ginormous, there's really no like pure model. Everything's a hybrid or pulls generally from both models, but there's essentially the idea is that carbon has a value. Carbon has a cost, right? We all know what it is. Everyone remember what the tragedy of the commons is from the first week? Right? Tragedy of the commons, where we have a shared resource that we all need, but nobody owns it, like the ocean or the atmosphere or biodiversity. And so we kind of use it as a dumping ground. So obviously carbon has a cost from a planetary system, and the question is, how much is that cost per ton of emission? And if you remember that, we write that CO2E, right? CO2 equivalency, because there's 6 greenhouse gases. We convert them all to carbon and then talk about 1 metric ton of CO2. So that's what we're trying to figure out, what's a market-based value for that. And then you can incorporate that in the cost of your products and services and businesses and communities. There's two basic models. One is carbon taxing, and one is cap and trade. Carbon tax is great. The people that are proponents of that like it, because we know with predictability exactly how much carbon is going to cost. Because when you publish a tax, or when the legislature approves a tax, you know what the percentage is, or the per metric ton cost. But what we don't know about it is how much it's going to impact global emissions, right? So we know what it's going to cost, but we don't know how much that's going to cause companies and people and communities to ratchet back, okay? Whereas with cap and trade, it's exactly the opposite. Cap and trade, you know exactly how much you're bringing back or reducing emissions, but what you don't know is what it's really going to cost. So there's just, these are differences in policy modalities. The United States made a commitment to the international community with the Paris Climate Accords. As you all know, we have recently backed out of those. So we currently have no international commitment to greenhouse gas reductions. Okay, so taxing right now, there's about 46 countries that currently tax carbon, and that's built into the cost of their products and services, right? Carbon capping, there's sort of so people that believe in this point towards SO caps that we implemented in the 70s. Sulfur dioxide. Sulfur dioxide caused acid rain. You guys are all too young here to remember what that is, but I remember it very vividly as a child, certainly not where I lived in South Dakota, but looking at the pictures, particularly out east, of Philadelphia just coated, it was raining black toxic particles because there weren't scrubbers on industrial plants, right? So the CO2 or sulfur dioxide was just being emitted. It was accumulated in clouds, and then it was dispersed with precipitation. And we capped it. We capped the amount. It was a pretty big crisis. Whole river sheds were dying, fish were dying, and human health obviously was impacted. So we capped the amount of SO2 or SO that could go into the air on an annual basis, and companies complied with it by buying scrubbers and catalytic converters, and the problem of acid rain just went away. It's just a thing of the past, right? And that was accomplished by capping. How many tons of SO a year can be emitted into the atmosphere? There's different ways to do carbon capping. I'll talk about this a little bit later, but just to familiarize you with the words. And the example I'm going to go over is the first one of actually allocating units of carbon to different kinds of industries. Units being tons. Auctioning them off, right? I'm a really heavily polluting industry and you don't pollute at all or very little. So let's all go to the board and bid for our amount of units of CO2 that we can emit on an annual basis. Immediately you can see that there's lots of issues with that because you really want your government to be an auctioneer. I mean, that just screams corruption. And then a cap and dividend system is the last one, which just in a very, very short layman's terms overview is a rebate system. One of the problems with both taxing and capping is that it disproportionately affects lower income people because their power bills occupy a lot more of their disposable income than higher income people, right? I make 200 grand a year and it costs 2,000 to heat my house. You know, that's 1% of what I make. If I make 20 grand a year and it costs 2 grand to heat my house, that's 10% of what I make. And, you know, that's significant. So if you're all of a sudden you're upping my bill by 15%, it's going to disproportionately affect me. So a cap and dividend system recognizes that and returns in the form of a dividend to lower income people part of that carbon tax or that cap. Okay? But obviously where does that come from? Higher income people. Higher income people don't like to pay tax so much. So you know, you can already see there's a lot of inherent problems. And again, it's back to kind of culturally. Like places like Japan or Scandinavia, where communitarianism is culturally accepted. It's like, okay, we've got this problem, we're all willing to participate in the solution, and yeah, we're all going to have to give, you know, like put a little skin in the game. It's not really that's just not culturally how we flow in America. We're individualists. You know, the harder you work, the more you get. And we're not so good at redistribution of wealth or resources for the good of the community. That's just not culturally how we roll. Okay, so carbon taxing it's called an upstream tax, and of course it's based upon the carbon intensity or the embodied carbon in different kinds of fossil fuels. And like coal and bitumen, for example, bitumen is a type of really dense coal, have a much higher carbon content than, for example, liquid natural gas. To get to liquid natural gas, you have to frack. So I mean, you know, there's different kinds of, but of course with coal you do mountaintop mining where you blow up the top of the mountain. So I mean, you know, everything's also got its like ancillary problems, but this is just based on carbon content. Obviously, a carbon tax will raise fossil fuel prices. That's the point. I'm sorry, this first little bullet instills crucial price signals that spur carbon reducing investment. So this goes back to the example of the sulfur dioxide. If I owned a textile plant that was spewing a bunch of sulfur dioxide and I chose not to put catalytic converters on, in other words, I chose not to make the investment to it, the penalties would be so onerous that it was just a stupid business decision. It made more sense to invest in the catalytic converters than to continue to pollute. That's the point anytime of taxing pollution, right? So again, the impact on household can be softened through dividends, tax shifting, swapping, all those words I will just tell you in a very capitalistic society are hot button words. People don't like to see things like tax shifting or wealth redistribution. That makes them very nervous. Pro-carbon tax folks will argue against cap and trade because they believe that cap and trade, which actually has proven to be true, in many markets, there's ways to manipulate it, and there's winners and losers, whereas a carbon tax, the contention is evenly just, you know, everybody pays X amount of dollars per ton of carbon they emit. You and I would see it on our at the pump. You and I would see it on our Northwest Energy bills. You and I would see it when we go to the grocery store, because every single thing that is transported agriculturally is going to go up because there's carbon tax embedded in it, right? Because you got to move it from point A to point B. Okay? All of a sudden, maybe buying local is going to be cheaper than buying something that came from Chile. Okay, so that's got some good ramifications too. Okay, so do you feel like you kind of understand what a carbon tax is? What does this show? I gotta put on my glasses. It's pretty. As countries prepare to meet Paris climate goals, more than 100 are using or considering using a carbon price. Okay, so these are in green, so Mexico, Canada, you can kind of see this. Domestic carbon pricing in blue, oh, interesting, South Africa, Australia, Japan is a domestic carbon pricing. I mean, you can read this map as well as I can. Obviously, the United States, not so much. Okay, cap and trade. Here's how cap and trade works. Cap and trade, and this is not my area, so forgive me if I bumble a little bit. This was prepared by Molly White. She worked for a company here in Missoula called Clear Skies Climate Solutions that sold offsets. And so she prepared this, and I'm speaking from her slides, and again, this isn't exactly my area, so bear with me. So what A means is an annual allowance. So hypothetically, we've got 100 tons in year one of CO2. And I allocate 20 of those tons to the, what is that, a nuclear power plant? To power plants. I allocate 30 of them to transportation. No, sorry, the first one is factories, manufacturing. Second one's transportation. Third one's nuclear power. And the fourth one is drilling, obviously, oil, fossil fuel extraction. But every industry you can think of would be represented there. They're just using four for illustration purposes. But, textiles would be in there, and agricultural production would be in there, and chemicals would be in there, and et cetera, et cetera. And every industry sector would get X amount of chits, right? Tons. So, okay, great. So that's what I'm allocated in year one. In year two, the whole point of cap and trade is that there is a very strategic, identifiable ratcheting back in the number of units per year. So in year two, you don't get 100, you get 96, and this is what's going to happen. So the message that cap and trade is sending to these different industry sectors is, hey, plan for this. Well, what happens? Great. So a couple of them are like, okay, we're going to be planful and mindful, and we agree that it's for mutual benefit and poising ourselves for the future, sustainable future in business. We're going to do just what they told us to do, and we're going to ratchet back. And some industry sectors aren't going to do it. So in the first year, up top was the ones, remember, were the original ones. But what really happens is nuclear ratchets way back from their 30 to 20, and oil goes over. Okay? What happens there? What do you imagine are some scenarios there?
We'll just buy carbon offsets and hold all the time.
You can buy offsets for the 10 that you went over.
I don't really mean that.
No, that was said with a facetious tone. Yeah, you can buy offsets for the 10 that went over. You can purchase them from nuclear. Nuclear's got some to sell. Right? So those are basically the options. So the good news from the scenario is we stuck to the 100. The bad news is that one of the industries has not shown any incentive or any inclination, obviously, to reduce their footprint. Okay, so that's not good. So what are these mythical offsets? It's 1 metric ton of carbon dioxide that's taken out of the atmosphere or prevented from being emitted. Okay? Or prevented from being emitted. So that's a whole nother animal, isn't it? Taking carbon out of the air and sequestering it, there's tons of technologies to do that. Preventing another one from being emitted is like replanting a rainforest that's been denuded. It's handing out condoms in rural South Africa to reduce population rates. It's changing out all the old, very inefficient light bulbs in El Salvador for LEDs, right? It's preventing future tons of carbon from being emitted, and it's all mathematical. Light bulb A emits this amount of carbon, and light bulb B emits this amount minus 62% of carbon. And then you just do the math, and you figure out how many light bulbs it takes to make 1 ton. And you replace those, and guess what? You just got a carbon offset. It gets a little dodgier when you're doing things like birth control, but not really. You can do the average footprint of somebody in South Africa and say they emit, what were our numbers? 20, 25, 30 tons a year. So rural South Africa, probably like 4 or 3 tons, right? So if I prevent X amount of births, it's just math, it's just modeling. And then you sell them. You sell the offsets. You see where there's problems with this already? What kind of problems? Like I buy offsets to fly. And I buy my offsets are based on reforestation. Do I ever get to go see the product I purchased? Yeah, I don't go to the Amazon to see the product that I purchased. So what do I have to do? Trust. Completely trust that who I'm buying it from is going, first off, and doing, have got proper scientific foresters that are doing the calculation of, if you have this amount of biotic density, it's going to sequester this much carbon, and that's going to offset my trip to California next week. I don't know that that's happening. So I have to rely on third-party sources to tell me that they're verifying that my offsets are authentic. Okay? Because as you can imagine, this is one of those things that it's very easy to get in and be like, oh, look how green I am. When I first started teaching this class in 2007, there were 6 offset providers. When you Googled carbon offsets, 13 years ago, there were 6. I don't know now, but I bet you there's 600,000. Everybody's selling carbon offsets. So you get the point. The goal is to ratchet back every year. What are the different kinds of offset projects? And these are just some examples. So
I have a question, Missy. So how does that work? I mean, is there any sort of regulatory boards that monitor
there's
this?
a dozen of them.
Why can't we just set up a company and say we're selling carbon offsets and this is...
You could. And if you could get somebody to buy them, you'd be probably no different than half the businesses on the internet that are selling something that's, not viable.
Plus we have time machines and bridges.
Right.
Okay.
Yeah. So credible projects. Forestry is a huge one. Obviously, directly producing renewable energy is another one. My offsets go directly to putting up wind turbines on the Columbia River Basin. That's super measurable. A big one in Montana is methane destruction. You guys saw flared methane. Do you remember where you saw that? Where was that? Yeah, the wastewater treatment plant. And did they capture that?
They captured and they used that energy back in.
So why did we see the flare then? If it was being captured.
They captured some of it in the part of the plant.
Because I remember him talking about using it as like a biogas to heat,
Well, wasn't
but we
that-
saw the flare.
Well, so wasn't that what they catch? Wasn't that in the weird boxes outside of that building?
Okay.
Right?
Okay.
And then, I don't know why.
And maybe from an engineering standpoint, you do have to still free flare some of it.
Yeah.
I don't know. But I do know that this is a very big deal in our dairy industry, where does methane come from cows? Yeah, from their manure and from their gaseous, whatever, they've got like 4 stomachs or something, ungulates. If they produce a tremendous amount of methane, capture that methane and use it to heat your farmer, your barn.
Hull's Dairy does that down, that's actually, they're related to my husband, and they were leaders in.
I think this is at Hull's Dairy.
Oh, it could be.
I think in Victor.
Yeah.
Victor.
They're outside of Corvallis.
Okay.
Mhm. But yeah, they capture it and use it for the powering their facilities. And then also another cool effect of that is that the manure that's been sort of treated through whatever their process is, it's better for fertilizer. Because it takes out a lot of.
They put it in big vats, the manure, and they do this all over Africa. We saw this in rural Africa all over the place, and cows, they have yaks and whatever, but yaks. I don't even, I can't remember. A giant ungulate, whatever they have in Africa, I can't remember what it was. It's some sort of, they were like water buffalo or Cape buffalo, that's what they were. But they take their manure and they put them in big cisterns, and then they just put it, like in Africa, it's very primitive. I mean, they just stick a tube into it, and that the methane, I guess, naturally decomposes and comes out of the tube. And then they capture it in cylinders, and they use it to cook with, or to heat their huts, or to, basically that's the 2 things they would use them for. So and then she's saying here, once the methane has been extracted or biocomposed from the manure, the remaining manure is a much healthier fertilizer for the fields.
And it clears out a lot of the, bad seeds and stuff where you would get weeds and whatever.
Right.
There's like, I don't want to say sterilization process because that sounds bad, but it actually does inhibit, the bad stuff that you don't want to be throwing into your garden.
Right, great. So these are kinds of offset projects. So they just kind of, let me see how many more slides. Okay, I'm good because I do want to get through these last 3. So this is super important. These are the qualities that you want your offset to demonstrate. Obviously, it needs to be real, meaning measurable. You got to be able to put it into some sort of mathematical model that I have just described. Additional. So I'm not gonna denude that 1,000 acres of rainforest. I'm gonna sell it as offsets, but then I'm just gonna go to the next 1,000 acres and take it down. Well, that's not additional. That's just moving it. You can't sell an offset if you're just moving the destruction or the additional carbon somewhere else. It's got to be permanent, and this was a big controversy early on in the offset world. So I'm going to do a one-off shot where I harvest my methane, and then it's like I quit doing it. I can't sell, obviously that, it's got to be repeated every year. It's got to be a permanent offset. So if I reforest the rainforest, I can't let it grow for like 5 years and then denude it again. Leakage, I'm not 100% sure that I can identify that. I mean, the ton's got to be the ton. Leakage means it can't be reduced. They should be certified. The next slide is going to show the different agencies that certify carbon offsets. They're actually given identification numbers, so you can't sell the same offset twice, right? Verified, that's third party, which I'm going to show you. And then ancillary benefits is what's some of the other good stuff that happens when you're engaging in the offset. So for example, when you're reforesting in the Amazon, it allows indigenous people to go back to nut harvesting, or it allows sloths to come back, or there's like other things that happen that are good, ancillary benefits. So these are high quality carbon offset, demonstrates these 7 attributes. These are the voluntary registries where you register each unit of carbon, so it can't be, or offset, carbon offset, so it can't be resold numerous times. And then these are the different organizations that certify or regulate carbon sales. Like everything we've seen in this class, it's in its infancy. So it's not profoundly established. There's a lot of, not chaos, but, go ahead.
Growing pains.
Yeah, there's tons of growing pains. Great simple way to put it. There's a ton of growing pains. It's in its infancy. Yeah, so this is just some beautiful photos I'll end with. This is in Panama. This is a project that we saw. So you can see that the land is completely denuded. They do that in Central and South America for what? Why do they denude the rainforest?
Agriculture.
Cows. Yep, raise cows. Yep. So you can see here it's denuded. They're replanting, and in equatorial countries, the biomass grows so quickly because it's so hot, right? It's fecund. So, so here's what it looked like, and here's what it looked like in the nursery. They're planting it, and this is in 10 months. Look at how fast these trees grow. And look at this in 9 years. Look at this rainforest recreated in 9 years. They got ocelots back. They got spider monkeys back. That was a pretty cool example. Oh, here's hulls. Yeah. So the bottom line is carbon taxing, cap and trade, 2 different policies. Extraordinarily difficult. We've talked about this legislatively, but we have to continue to pursue these policies in some way, shape, or form if we're ever going to get to our goals. Thank you very much.